Over the last year or so, I've noticed a slight issue with my mill that's been getting worse. Let me show you what that is. You hear this squeaking and then how this rattles really easily? This is a problem for two reasons. One is when I'm out here working by myself, the squeaking is generally annoying. And then the rattling gets really annoying too, especially when you're doing something like face milling something or using the fly cutter. Just hearing this, just this rattle for minutes on end gets really annoying and really old quickly. The other big issue is when I'm actually making a video, the squeaking that the hand wheels can make is actually so loud at times that it can actually blow out the microphone in the camera. It basically goes to the maximum level and then causes what's commonly called clipping, which sounds horrendous, and I've actually thrown out a lot of footage because of that happening. So I've gotten to the point now where I'm fed up enough that I've decided to fix that. Let me take you over to the bench and I'll show you what I'm going to do. Here you can see the heart of the issue. This is the two components for the fine down feed on the head. You have this poor facsimile for a shoulder bolt. Nothing is too close to tolerances, or close to standard dimensions, I should say, imperial or metric. And then the handle body itself. As I mentioned, there's quite a bit of slop. And as you can see, the surface finish on both of these parts is not great. And it's of unknown material. So it's not like this is a hardened steel shaft with, something riding on it. It's most likely pot metal because it feels too heavy to be aluminum, but it doesn't feel hard enough to be anything else. And thus I'm getting a bunch of horrible noise. So this is the prototype that I made that's going to fix that problem. So the first thing, good tolerances. Standard shoulder bolt, in this case 8mm, an aluminum body that has MDS impregnated nylon bushings pushed into each end. They're a really slight press. I've already tested this out. It rides nice and smooth, doesn't make a sound, doesn't rattle. So let me prep some stock and then I'll take you over to the lathe. I've gone ahead and chucked up a piece of the nylon. First thing I'm going to do here is clean up the end. I could turn down the outside first, but I want to have as much stock, as much meat as possible, because I want to drill it first and then bore it to size. I think that'll be better than turning it down and having a thin wall piece to bore through then. The final hole size is 10mm, so I'm just going to go through with a 9mm bit. And I'll take the rest out with the boring bar. One of the nice things about working in plastics like this is that with a drill bit, you can just plow right through it, unless you need it to be to a precise size. Then you gotta go slow. I'll take a cleanup pass and I'll take a measurement to see how much I have to remove. Just using a little tiny, actually my smallest telescoping gauge. Oh, it didn't come out right. It's actually kind of difficult to do this. I'm not used to doing it in holes this small. Okay, so I've got another 30 thousandths to come out. I've got to take another 2 1/4 thousandths out. And the shoulder bolt fits nice and correctly, so boring operation is done. Next step is to turn the OD to size. Actually, maybe I should mention this. I think you can probably see it. This is just a high-speed steel turning tool. It's actually one that I have ground for aluminum. I don't really use high-speed steel a lot anymore since I have pretty much all insert tooling. But it's got a lot of side rake and then a lot of back rake as well, as you can probably see there. And the nice thing about using a sharp edge tool like this is that it'll just peel away this nylon without any problem at all. So the first thing I'm going to do is take a skim cut here to get an initial measurement so I can figure out what I have to take off completely. So I need to take just over 100 thousandths off. So what I'll do here is I'll take 80 off the first time. As you can see, this nylon makes a nice continuous chip that's not that hard to dispose of. Now we're in spec. And see, that's one of the things I like about working with plastic like that. Just being able to shave like 3/10, 4/10 off. Much harder to do in metal. So the next step here is to part this off, do it a little long, because once I get all the parts turned down, I have the rest of the bushings and then the two handles themselves turned down. I'm going to swap this out for the 5C chuck. So I got more than enough material, and I will clear the chuck. And that's it for that part. So let me go ahead, I'll do the rest of these bushings, rough them in, and then I'll come back for the handles. So I've gone ahead and mounted up a chunk of aluminum that's roughly the right length. I am going to stick with the high-speed steel tooling that I used on the nylon. I mean, this tool bit was originally designed and ground for nylon, for aluminum, not nylon. Plus, it's going to let me take a lot of light cuts because there's quite a bit of stick out, in my opinion, for a chunk of aluminum like this. If I were to try and take, like, even with this tool, which is going to have a lot less tool pressure than my carbide tooling, like 30, 40 thousandths deep, it'd shatter. So this is going to be an operation, you know, kind of a sequence of light cuts, let's put it that way. So it's not exactly going to be fast, but it'll be good enough. So the two things I'm going to do before I have to switch over to the 5C chuck, and that is to face the end and then turn as much of it as possible down to the proper length. Now I'll take a measurement and see how much more I have to remove. So this should indeed be the last pass. Taking off exactly 2 thousandths. Get this out of the way, and I'll see if we're to size. And we are. So that's it for this one. I'll swap over and do the other one off camera, and then I'll switch out to the 5C chuck. Okay, I've got the collet chuck mounted up. So the first thing here is going to be to bring these bushings down to length. Nothing really special about it. I've done the first two, the smaller ones, and these last two, which are the larger diameter ones, are both about 1/8 of an inch too long. So the first thing is going to be to get a clean face on this side and then flip it around. Okay, should have two nice clean parallel faces. So let me go take a measurement and see how much more I got to take off. Okay, for this one, I have to take right at 120 thousandths off. So first step here is to get it back in. And then what I'm going to do is come back and carefully touch off. There, I just started to take a cut. I'll set my dial indicator here. I'm going to take 50 thousandths off. There's another 50. And then we'll take the final 20. Now it's time to see if I'm in spec. .503, and the tolerance was from 0.5 to 0.505, so I'm just about right in the middle, which is good. I'll do the other one here off camera, and then I'll bring you back when I'm going to do the aluminum handles themselves, because the remaining stuff is just repeating what you just saw. So for the aluminum housings, just like the bushings, we have to bring it down to length. Though, since it's blatantly obvious which end has been faced on this one and which end hasn't, we don't have to swap it around. So we just have to take a face cut off this, take a measurement, and then determine how much we need to take it down to size. Grab my calipers here. So to get the target, I've got to take exactly 122 thousandths off. Assume that is a thousandth. So I have to go 121 now. That's 50. Another 50. This one's 15. And then the final 6. If I can get my stop set correctly. There we go. So I'll pop it out here and see if I'm in spec. Yep, right in the middle. Maybe off by 3/10 or so, but I've got 5 thousandths to work with, so that's plenty good. So the next operation on this is actually going to be to drill and then bore the pocket for the small end bushing. For example, so there's the 2 bushings here, the big one and the small one. And the smaller one goes in the front because that's where the taper is, and then the bigger one in the back. Then we're going to punch through with a 30 seconds drill. Ideally this is for clearance, and it's going to be punched all the way through from one side to the other. There, it's all the way through. Clean up the mess here. Okay, so now I've got my dial indicator and my stop set, so I can start boring this out. Do a light touch off there. That looks like at least enough of a cleanup that I can take a measurement and get an idea. So I have 115 thousandths to take off the diameter. So I can take, let me just get up to a nice round number here. Okay, let's see here. Took a little bit of finagling to get that last little bit out. There we go, and that does go in. And it does push down just about where I want it. It's time for the fun part, and that is to machine the taper on the end of the handle. So chuck this up. I want about 1 3/4 of an inch sticking out. About there. Should be good. RPM set at 1,000 RPMs. I've got the compound set to 4 degrees. And I think I should have this pretty close to being correct. So I'm just going to touch off, and then I'm going to feed it through. And with it, machine being at 1,000 RPMs, it's going to be hard for you to hear me talk. So there won't be really any talking while this is going on. Take a measurement here and see roughly where I'm at. So that's it for the tapers. I've already done the other one. And you might have heard what sounded like a different motor in the background, and that is, so I can get this in frame, my electric drill. So my compound has 2 little handles on it, and as you can imagine, turning the taper using the compound's a pain in the butt. So what you can do is just, in this case, this is just a T-handle Allen wrench. I just chuck it up, put this between the handles, and then I can turn it one way and turn it the other way. It's simple. Other guys had different ways of doing it, but this is pretty quick, pretty simple. Doesn't require me to make anything, and it's just right around the corner on the wall. Just grab an Allen wrench, or a T-handle Allen wrench and go to work. Let me flip this around, and then we'll get on to the final part, which is boring the hole for the back bushing. So machining the back bore is pretty much like machining the front one. It's just larger in diameter and deeper. Got it opened up to a decent size, so I'm going to take a measurement here and see how much more material needs to be removed. So we've got 80,000 still to come out. And that should be the final pass. Let me take a measurement and I'll confirm that. That is the correct diameter. I'm under maximum tolerance by about 1/2 thousand, so all I really need to do now is chamfer this, clean it up, and then I can install it. So let's see here. Presses right in. Let me clean up a little bit here, and I'll take you over to the mill and we'll actually see how this sounds and if it's an improvement over the old ones. I've already gone ahead and mounted the handle for the X-axis. So now just the Y-axis is left to go. The X-axis handle feels as good as I would expect it to. It's quiet and everything, but it's also got a lot less weight that it's got to move. And see, I like this a lot. Quiet, handle's not free spinning, I mean, it spins freely enough, but you know, it's not gonna freewheel. Same thing with this one. The only question I have, and that's something I can't readily answer, is how well the nylon bushings will hold up over time. Hopefully well enough. If they don't, I can just drill or cut them or bore them out and press some new ones in. So overall, I am really happy with this. It's going to be a lot less annoying to use my mill for long periods of time.